Hello class. In this video I'm going to talk about negative exponents and what happens when you come across one in a problem. But before that, I do want to explain to you where all this rule is coming from. We don't like negative exponents in general, and we want to take care of them as soon as we can. So before that, I want to understand why negative exponents get the value that they do get. If you look at the pattern, there's a pattern in math to explain this. So let's say we start with, let's have 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd, and 2 to the 1st. So these are pretty much the easy ones that you've seen before. We get 16, this is 8, this is 4, and this is 2. But I want you guys to look at the progression, like how do you get certain numbers? Well, if you look at 16, in order for me to go from 16 to 8, I would have to divide it by 2, right? From 8 to 4, I would have to divide by 2 as well. Same thing goes with 4 divided by 2. Okay? Basically, you're dividing the base that's sitting on this side right here. Okay, so if you look at 2 to the 0 power, right here, if I were to continue this pattern, I'll take 2 and I'll divide that by the same number. 2 divided by 2 is 1. Okay, so that's why 2 to the 0 power equals 1. But what happens when you have a negative exponent? Because you can continue going down this list. Well, 2 to the negative 1/2 power, if I take the same rule, I'll take that 1 and I'll divide by 2. We all know that 1 divided by 2 is 1/2. So I'll put 1/2 right here. And if I keep going, 2 to the negative 2 power, I'll take 1/2 and divide that by 2. So this will get me at 1/4. Well, why is that? Well, if you look at the laws of exponents, which we will in a second, whenever you have a negative exponent, we kind of want to push it down the fraction bar. So technically, this is my fraction bar I have here. I can never have a negative exponent. In order for me to have this number, though, I want to push this number that's sitting up here down underneath this fraction bar. So really, that's going to be 2 to the 1st power. All of that is over 1. Okay, so 2 to the 1st power is just 2, so that's why we get the answer of 1/2. If we look at the next one, I don't want that negative 2 floating up there. So the only way I can do that is if I push this number below the fraction bar, so I'll have 2, and then now I can finally have a positive 2 exponent, but that's going to be over 1. Well, we know that 2 squared is 4, so really this whole thing is 1/4. Okay? I want you to see another example before we look at the notes. Again, I don't like having a negative exponent. Here's my fraction bar. That's technically sitting right here right now, so I want to lower it down to this bottom of the fraction, so it'll be 2 to the 3rd power. The numerator is 1, so if we know based on our exponent powers, 2 to the 3rd power is 8, and that is 1 over 8. You can check the pattern. If I take 1/4 and I divide it by 2, I do get the answer of 1/8. So that's where the rules come into place, where we don't want negative exponents, and that's why they go underneath the fraction bar. But sometimes, if you have, let's say, a fraction over, we have this, we also don't want a fraction bar sitting down in the denominator. So the only other place for it to go is up in the numerator. Okay? So obviously we can't keep going down here. It's impossible. We can't have double fractions here. So what we're going to do is now bring it up. So this is really going to be 3 squared, which equals 9. And you can check with your calculator. If you do 1 divided by 3 to the negative 2 power, you will get the answer of 9. Okay? So that's a little short explanation as to why numbers work the way they do. when it comes to negative exponents, and I want you to see some of these problems. Okay, so here's the rule. If you have a negative exponent, we cannot move anywhere except for down in the denominator. But now we have a positive n, and we never want, there's always this part of the equation where a does not equal 0. We're just trying to explain to you that whenever you have any number on the bottom, it can't be 0 because that will be undefined. So that's just basically a little spiel about that. But it's not really necessary for this. It's not really going to help you solve this problem. It's just like a rule that they're stating. So let's look at the first example here. I'm going to highlight here where I have a negative exponent. Basically, long story short, the x to the 4th power is the only one that stays where it is because there's no other x's that I have, so and there's no negative exponent, that's going to stay in the numerator. However, the y and a negative 7, remember we cannot have a negative exponent, and in order for us to have a positive exponent, we have to either move it to the denominator or to the numerator, depending on where it is. So this right here, I have to move to the denominator in order for it to be positive number. So this number I'm going to switch down to the bottom, so it'll be y to the positive 7. And now this z to the negative 2, I can't have a negative exponent, so I have to move it up to the numerator. So move to the numerator. There's no other place to go except for up. So it'll be z to the positive 2 power. This is your final answer. Okay? So it's easier for you sometimes to see, okay, if this is negative, I have to go down. If this is negative and I'm in the denominator, I have to move up. It's just the opposites, okay? And the very last problem here that we're going to look at in this video, remember when we have to raise a product to a power. So basically, what we talked about in this part, the second rule, when you have a power, you're going to multiply it. If it's being raised by another power, that's exactly what we're going to be doing. And I'm going to distribute that to everything that's in here. If you remember the distributive property, we're going to be multiplying our exponents. So this 3, I'm just going to keep it in the parentheses here, and I'm going to write negative 2. I have x to the 2nd power. So really I'm going to be multiplying that by negative 2. Z, I'm sorry, I'll have 0 times negative 2. And then finally y is going to be y to the 4th, negative 4th, I'm sorry, times negative 2. So you can go ahead and take a quick second to try to simplify this part of this problem. Alright, and here you go. I've simplified it. I have all my new exponents here. And notice that I still have one negative exponent. And that's 3 to the negative 2 power. Right here. I can't have that. Everything else is good to go. Oh, actually, never mind. There is a negative 4, so negative, which should be a negative 2 right here. A negative 2, so really that should be a negative 4. So really we have 2 exponents that should be moved down under the denominator. This z to the 0 power, I'll talk about that in a second, and then y to the positive 8 is because negative 4 times negative 2 gives you 8. Okay, so the 2 things I've highlighted, those 2 things are going to have to move down when we have a fraction. They can't move up because they're already sitting in the numerator, because technically this is all over 1, okay? But we don't really write that down to confuse us. So I'm going to write down my numerator, which is z to the 0 power times y to the 8th power all over 3 to the positive 2 power and x to the positive 4 power. Because I moved them down, that's going to be my new fraction. But I can still simplify 3 squared, and 3 squared is simply just 9. So the answer to this is z to the 0 power times y to the 8th power over 9x to the 4th power. One thing I do want to point out is the z to the 0 power. If you looked at our pattern before, anything to the 0 power is 1, even if it's a variable. So in this case, my final answer, once I simplified everything, I'll make this into 1. It'll be y to the 8th power all over 9 to the x to the 4th power. And there you go. Okay, so just remember in this video, the whole takeaway is you can never have negative exponents. If you do, you either have to move it down to the denominator, or if they're sitting in the denominator already, you have to go to the opposite direction of going up. Okay, if you have any questions about the negative exponents rule, please let me know in class, and good luck solving these problems. Okay, bye class.